Last but certainly not least, chemical reaction. A chain where one or more substances are turned into one or more different substances. Charcoal can be made from materials such as scraps and grass clippings. Material scientists can determine how much of each material to use. Manufacturing engineers change this matter into charcoal, water, and other liquids and gases. They put the matter into a large metal container and heat it. After about 2 to 3 hours, charcoal is formed. Know how you can identify chemical changes. Know how you can identify chemical changes. Okay, here we go.
New substances. If you take a piece of charcoal and break it into pieces, the smaller pieces will still be charcoal. However, something different happens when you burn charcoal. Burning is an example of a chemical change. A chemical change is a change that produces one or more new substances. When charcoal burns, a chemical change occurs in which charcoal and oxygen form new substances. These new substances are ashes and gases that you cannot see. Particles and chemical changes. When a chemical change occurs, the particles that make up the original substances rearrange to form new substances. It is not always easy to tell whether a substance has changed chemically. Evidence of chemical change may include the release of heat or light, a change in color, a new smell, gas bubbles, or the formation of a solid. You can use building blocks to model a chemical change. In the picture, the blocks represent particles of matter. They are connected to form two substances. You can connect them in other ways to form different substances. Conservation of matter. The particle diagram shows what happens when iron combines with oxygen gas. Iron and oxygen are the original substances in this chemical change. The new substance that forms is rust. You can use the diagram to compare the combined mass of the original substances to the mass of the new substance. Scientists have done many experiments to test whether mass changes during chemical changes or physical changes. Their data support or back up the idea that mass stays the same before and after any change, no matter what. From this evidence, scientists developed the law of conservation of matter. The law states that in any chemical change or physical change, the total mass of the matter does not change. In a chemical change, all the particles that make up the original substances end up in the new substances. So, the combined mass of the substances before a chemical change is the same as the combined mass of the substances after the chemical change. Wow.
So if you were to do this, ladies and gentlemen, with this model, each orange particle has a mass of 4 units. 4 plus 4 plus 4 plus 4 right? 4 times 4, which equals 16. Okay. Each mass of red particle has 1 unit. 1, 2, 3, 4, 5, 6. So when I add those up, 16 plus 6, 22. Know how to do this in case there's a question on the test, ladies and gentlemen.
Conservation of matter continued. Look at the nails. The shiny new nails are made of iron. Over time, the nails can rust. Rusting is a chemical change. The change occurs when the iron on the surface of a nail combines with oxygen gas in the air.
Wait,
to form rust. When you observe one or more substances change into one or more new substances, you observe a chemical reaction. The nails rust as a result of a chemical reaction. The iron in the nails and oxygen gas from the air react to form rust.
Wait, faster streams. Okay.
Examples of chemical changes. Chemical changes happen in the kitchen all the time. A chemical change occurs when a chef makes fresh cheese. To make fresh cheese, the chef adds lemon juice to whole milk. Once the two liquid ingredients are mixed, solid pieces start to form. The solid pieces, called curds, are chunks of the fresh cheese. They form as a result of the chemical change. To prepare the cheese to eat, the chef separates the curd from the liquid. Different kinds of cheeses are produced by further processing the curd. For example, to make soft, stringy cheese like mozzarella, the curds are kneaded. Many cheeses are aged. During aging, which can take months, bacteria in the cheese chemically change the cheese. Gouda is an example of an aged cheese.
All right, remember the pennies, the chemical changes. The copper of the penny combines with the oxygen in the air, and that makes it form that green substance, that copper oxide. That's another chemical change. Okay, these are the types of questions we're going to see on the test tomorrow. So make sure you look in your book. Make sure you look in your book. Review this. I want to get the very last piece up on the screen for you to see, to review. Properties of matter that hold. And the last piece is mixtures and solutions. We just finished chemical changes. So our final piece is mixtures and solutions, which we had the quiz on. And now it's part of the whole test. Okay. Make sure you know the difference between the mixture and the solution. So first off, the mixture. substance where different materials are put together, but each keeps its own properties. That's a mixture. The substance where different materials are put together, but each keeps its own properties. If I mix peanuts and raisins, it's a mixture. It's a mixture. A raisin still keeps its property, it's still a raisin, and a peanut keeps its own property, it's still a peanut. Okay? Whereas a solution, a mixture where the substances are evenly spread out. A mixture where the substances are evenly spread out.
Mixtures. If you mix peanuts and raisins, each of the substances keeps its own properties. In a mixture, different materials are placed together, but each material in the mixture keeps its own properties. In the nut and raisin mixture, you can easily separate the nuts from the raisins. Different parts of a mixture can be separated from the rest of the mixture. When sand and blocks are mixed, you can separate the blocks from the mixture by picking them out. You could also use a strainer to separate the parts. Some mixtures cannot be separated as easily as the nuts and raisins. For example, iron ore is a rock that is a mixture of different substances. One of these substances is iron. Large factories separate the iron from the other components, or parts, of the mixture. To do this, they use a lot of energy to make the iron liquid and separate it from the other components.
Hey, pay attention.
Solutions. If you place salt in water, the salt and water form a mixture, but the salt seems to disappear. That is because the salt water is a solution. A solution is a mixture in which substances are spread out evenly and do not settle to the bottom of the container. The substance that is dissolved in the solution is called the solute. The substance in which the solute is being dissolved is called the solvent.
You're going to need to know that, ladies and gentlemen. You're going to need to know the difference between a solute and a solvent for the test. You're going to need to know what a solution is. A solution is a mixture in which the substances are spread out evenly. They don't settle to the bottom of the container.
The salt dissolves in the water. Individual salt particles separate from the solid and spread evenly throughout the water. Ocean water is a familiar example of a salt and water solution. The water has a salty taste because salt is dissolved in the water. You can make solids dissolve in a liquid faster by stirring or heating the solution. Grinding a solid into smaller pieces will also help it dissolve faster. Not all solutions are made by dissolving a solid in a liquid. Two liquids can make a solution. For example, vegetable oils used in cooking might be a solution of soybean oil and sunflower oil. A gas can also dissolve in a liquid. For example, water can contain dissolved oxygen and carbon dioxide gases.
There's a lot to know. There's a lot to know. So know when a mixture is also a solution. Know when a mixture is also a solution.
Separating solutions. The components of a solution keep their own properties, but they usually cannot be separated as easily as other mixtures. That is because the components of a solution are evenly mixed. You cannot pick out chunks of one material from the mixture. You cannot remove a solid component with a filter paper. Its particles are spread out and become part of the liquid. However, the parts of a solution can be separated. To separate the parts of the solution, you use physical properties of the substances in the solution. Mixtures and solutions. Remember that all solutions are mixtures, but not all mixtures are solutions. You can tell the difference by observing the mixture closely. A solution is the same in all parts. For example, clear apple juice is a solution. Many samples of the juice are just alike, and there are no separate particles in the mixture. Fresh squeezed orange juice is not a solution. You can see chunks of orange in the mixture. If you let the orange juice pass through a filter paper into a glass, it will separate. The glass will contain a clear liquid, and the filter paper will have solid orange pulp. You cannot separate a solution by filtering it. To separate a solution, you have to cause a physical change to one or more of its components.
I'm going to stop here. That's our whole chapter. I just reviewed with you everything that we've done. Now, I'm going to stop sharing my screen for just a moment because I want to bring you up to date on those 2 quizzes that are missing from a bunch of people that should have been turned in yesterday. So, we had a math quiz and a science quiz. Tomorrow we have a math test and a science test. For the math quiz, I don't have the following people's math quizzes: Kostas, Lucilla, Zane, Brad, Lorenzo, Kamari, Tatiana, Kevin, Egypt, Andrew, Amria, Josue, Nathaniel, Lara, Kelly-Mar, Samantha, and Destiny. If I did not say your name, that means I already have it and it's been entered in the grade book. Now, science quiz. I do not have science quizzes from the following people: Lucilla, Brad, Lorenzo, Mari, Tatiana, Kevin, Egypt, Andrew, Josue, Nathaniel, Lara, Kelly-Mar. That's it. Now this is what's going to start to happen, ladies and gentlemen. Right now I've not entered grades in the grade book. What I'm going to do is I'm going to be putting in zeros, because the day that you take a test, if we were in school, I would be collecting that paper, I would have your papers. This is not acceptable. This is not acceptable. So what I'm going to be doing is I'm going to be putting in zeros. When you send me that test, that'll be a different story. Whatever you earned, I will give you, and the zero will come out, and I will put in what you earned. But for the time being, zeros are going in the grade book, because I should have had them by now. Okay? This is how it's going to be. And this is going to be for the rest of the year. We're going to see it this way. I need you to understand that you have responsibility to get me that information. If there's a special, something's going on, especially